The overall goal of this procedure is to non-invasively measure the concentration gradient in a microfluidic device by using the micro-schlieren technique. This is accomplished by first constructing the micro-schlieren system from a Hoffman modulation contrast microscope. Remove the slit plate of the condenser and replace the modulator at the rear focal place of the objective with a knife edge. The second step is to mount a T microchannel and start a calibration mixing procedure. Image the T channel in order to obtain grayscale micro-schlieren images. Next, compare the micro-schlieren images with a computational fluid dynamics simulation to find the relationship between grayscale and concentration gradients. The final steps are to load a target microfluidic device, take a micro-schlieren image of mixing, and use the calibration curve to convert the grayscale values to concentration gradients. Ultimately, micro-schlieren technique is used to show mixing inhomogeneity quantitatively in a microfluidic device in real time.
The main advantage of this method over the existing techniques like fluorescence imaging or shadowgraphy is that it enables unsteady full-field measurements of concentration gradient that reveal the three-dimensional inhomogeneity in a microfluidic device. Demonstrating this procedure will be Dr. Tzu-hsun Hsiao, a recent PhD graduate from my lab.
The first step is to prepare the microfluidic device to be used in the experiment. This T microchannel device was fabricated by